Okay, so last week we finished how we could do the network bonding, okay? So what happens in network bonding? If if you have one network card go down, the other one will be up, okay? All right, good. So let's see. Network. Before I move on, um, so everybody's clear about this here, right? How the network IP address work? It's pretty simple. So what you will have is, if you have 0.0.0/0, that means you have 4 billion IP addresses available, okay? And from here to here, between 128 and 0.0.0, there are 2 billion IP addresses are available, /1. And then when you do /2, so the more number it goes up, it's a halving itself into half, okay? So we have 4 here, 2, then 1, then 500, and 200. So it's reducing itself here. And you see the number is increasing on this side. Okay, so yeah, don't worry about this. It's not that, I mean, it gets complicated here, but you don't need to worry about all this too much. Okay, so what I'm going to do now is, let's see here. Okay, I'm gonna start today disk management here. So let's see here. Okay, so let's see here. What will happen in Linux is, we'll see here. Okay, so okay, so in the Windows, let's see here. Okay, so in Windows, we have what we call it is at least we need a one hard drive in the Windows here. Okay, so the very first drive in Windows environment is C drive. Okay, and then if you have a secondary drive, it will take up a number assigned by the system. That would be D. And then I have E here, drive E as a DVD drive, and then I have another drive here as a F here. So you could go on and continue on a lot of drives in here. Okay, so I'll explain you how this works in Linux here. So in old days they used to be called IDE. IDE. Okay, so this is a Linux will handle okay, so if a drive is IDE, the drive which is being used is IDE, the Unix will handle it dev/hda. Okay, and if it's SCSI, it's a name of a technology. Okay, So the Linux will handle it. dev/sda. Okay, and then the virtual drive. Linux will handle these disk dev/sda. Okay, so in our environment here, so I'm using this drive here. I mean this virtual machine, and if I go into settings, and then if I go into storage, I have one drive attached here. Oh, okay. Now don't look at this. Look at this here. One drive attached here, and this is a hard drive. Like imagine this as a physical hard drive attached to the system here. Okay, so the physical drive which is attached here is identified here as SDA, dev/SDA. Okay, sorry, this is dev/VDA. So LSBLK. So we have, when you type this command here, LSBLK, it will show you the drive which is being used now. So we have SDA. Okay. So the Linux handle this drive as a such here. Let me show you how. So for SCSI drive, the very first hard drive will be /dev/SDA. First primary disk. Okay. And then if it's a second drive, if I go in here and add a second drive here, right? I have to shut down to add it. If I add second drive here, it will be dev/SDB. And the third one, dev/SD. Can somebody tell me what would be the third one?
SDC.
Yeah, SDC. So here's the news here. So it will go on, and then it will reach to dev/SDZ. Okay, so this will be the 26th drive. So that's not enough here. What will happen is Linux could handle unlimited of hard drives. So 27th will be dev/SD. It will start back up again A, then start another letter A next to it. Okay, this will be the 28th drive. What the? Okay, and 29th will be dev/SDAB. Okay, now I think you guys get the idea here. So you could see the Unix Linux could handle almost unlimited amount of hard drives here. Okay, I think the most I've seen so far is about 22 hard drive up until like SDY or whatever. So the primary disk, this is like a C drive here. Okay, it installs Linux is installed here. On this drive. Okay, and this is also called a OS drive. So if you look in here, when we install the system, it did SDA. SDA is the only one drive in here. And then the system did some automatic partitions here. We'll go over that. We'll definitely go over that, what those are, okay? So, but here, let's go into /dev, cd/dev. This folder is a root partition. We talked about the folders, right? When we talked about the folders, here, editor, basic commands, I think early on I talked to you about what each folder does, right? Date. Okay, so here are the folders here. Directory structure. And here I mentioned /dev. It contains all the devices information here, okay? So if we do ls here, so this has all the devices in there. These are all, most of them are virtual devices. That means these are designed to do something for you. So don't worry about all this here. You're not going to be using this. Let's see, where is our SDA? Okay, so our file SDA, the hard drive information SDA is written here, and there is a partition on this one here, SDA1 and SDA2. Any partition, anything you're making here is also written here, okay? So okay, what I'm looking at here. Remember null, this is where null is at. So these are all the extra system generated stuff here. So you don't deal with that a lot. You just deal with the devices here. So let me clear this. So to see how many devices, their drives are connected, you type lsblk. So you see here SDA is def/SDA. This is what it looks like. SR0. This is probably your ROM here. This is probably this here. So if I remove this, so to add this here, we're gonna have to shut this down. So let me shut it down. Okay, so what I'm gonna do is, what do I do? So on a virtual box, you go into settings here, and you go into storage. Okay, and if you do select this and if you remove it, when you turn it back on, it will be gone. This is a IDE controller, and this is a SCSI controller. So let's add a hard drive in here, okay? So let me add a hard drive, add a hard disk. Okay, and then let's select create new. And then we need the, so you keep it the virtual one, VDI. Keep the one which selected as default here, okay? And then click on expert mode, and then add 16 GB. Okay, and then click create. So we have a new drive in here, which is 16 GB, and then okay, yeah. All right, so let's go on. I'm going to start this on now.
Question.
Yeah.
So when we are creating a new hard disk, so we pick VHD, right? Virtual hard disk. We are creating a different one, or the virtual box disk image. Which one am I using? Gonna create or VMDK. I have three options there.
No, which the very first one should be selected, right?
Virtual disk box.
VDI, yeah.
VDI. Okay.
Okay, yeah,
Thank you.
leave that on. And then
And then do I do fixed size or dynamically allocated, because it's giving me two options? Do I do fixed size?
no, dynamically allocated.
And
And
then
then
I increase it to, you said, how
16
much?
GB, 16.
60?
No, 16, 16.
16. Okay. Okay. Thank
Okay,
you.
yeah, sure. So now if I'm going to reconnect here, so I'm going to type my favorite command, lsblk. Okay, now we have a raw disk here. You have SDA. These are system generated, system is managing that. And then SDB. Okay, so let's see here. Okay, Okay, so let me take the screenshot here. So you go into settings and you go into storage. Okay, and what you do is oh, I have to. Yeah, I'll put that later here. You know what? Actually, I have to shut it down. Um, Let me shut it down. So you go into settings. Go into settings, storage, and then you click add. And add add hard disk. Add hard disk, and then here you select create new. And then you 16 here. Okay. And then you would click create. So we already did this here, so let me get away from this. And okay, so let me start this here. So a new hard disk is added. But it's not ready. it's not ready to be used. Okay, and if you do lsblk, okay, so you will get this output here. Let me restart this. Okay, so this is SDA1, SDA, and SDB. Okay, so let's move forward here. So we added a hard drive. So the hard drive is, we added is dev/sdb. I'm going to put a picture of a hard drive in here. Okay, so more or less we kind of added one of this physical drive here. Okay, just remember this as if you added a physical drive. Okay, so now we're gonna use the fdisk command. There is a old fdisk command which is coming down as a Unix command from the start of this Linux system. It's called fdisk. Okay, so we'll see how we're gonna use this command. So let me clear this. And fdisk. So first you have to type lsblk, and you have to identify the disk here. So over here it is telling you that this is a disk B, and this is the size. Okay, and RO is read write, and this is the disk, and this is the main physical disk here. So if you look at the SDA1, it says part here, that means it's a partition. SDA2 is a partition 2, and then within that partition you have two logical drives in here. So we'll talk about that later here. So let me just explain how the SDB is going to work with. So the command you use is, you type fdisk So you could go in here cd/dev, and SDB should be listed there, okay? So if I do ls-l, I want to grab SDB. So SDB is in here. Okay, so let's do the command. I'm going to type fdisk.
Hello, sir. This is Syed.
Yeah.
So I created the hard disk. It's not showing me, you know, the SDB used. It's not showing on the system.
What did you type? LSBLK.
Yes, I did that, and it only shows me SR0, not the one which I created.
Okay, give me TeamViewer.
Yeah, one second. I posted on WebEx.
Okay. Yeah, it's not here.
Yeah, I created it. It did create it, but I don't know why it's not showing up.
Are you sure?
No, that's not the one.
Okay, so go ahead and shut it down first. Okay, good now.
Go to settings,
Yeah.
storage. Oh,
Yeah, there you go. Right click, create disk.
it is virtual disk. Fixed size, correct?
No, 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 no. Don't go fix size. Go up dynamically.
Okay.
Go, yeah, and then type six. Change it to 16 here. Okay, so it does says it's already there. So just give it a different name here. At the end, just change it to something else. Yeah, there you go. Okay, so it's there. Now just okay and start it.
Yeah, now it shows.
Yeah, so you're good now.
So why, if we choose the fixed, it will not show up, sir? Is anything?
Uh, fixed one is I think fixed one is actually using the one which is already there. Did you try
Okay.
to use the existing one or no?
Sorry, sir?
Did you try to use the existing drive?
No, 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 no. When I created previously, I selected the fixed and gave 8 GB as the size, and it was not showing up. Then when I create using dynamically, it's showing up now.
Yeah. Well,
Okay.
the VirtualBox part, don't worry about it. You're not going to be using VirtualBox at work.
Okay.
So the physical hardware part will be done by it will be a site services team, so you don't deal with that. If
Okay.
somebody is offering you to rack and stack, usually it's called rack and stack, physically going into the data center and installing stuff, don't take that job, okay? I'm not training you for that job. That's
Okay.
that the lower paying job.
Okay.
So we are shooting for a system admin or engineer. It's a higher paying job, okay? All right,
Okay.
good.
Good. Thank you.
Sure. So we're gonna type fdisk slash dev slash sdb because that's what our fdisk drive is, okay? I'm gonna hit enter. So let's follow this. So now we are into the fdisk mode here, and you have M to view the menu. I'm gonna say M to view the menu. Okay, and then we have a bunch of menus here, but we'll go over this later, but not now. The one we are interested is in N. We're gonna push N for new partition. Okay, I'm gonna push N and I'm hit enter. Okay, so okay, now what we have is there are two types of partition. One is a primary and the other one is a secondary. On a disk, you could have up to 4 partitions, and then extended partition are unlimited here. So we're gonna just select P to P for primary partition. Okay, and I'm gonna hit enter, and then it says partition number. Remember, I told you could have up to 4 primary partitions, 1 to 4. So I'm gonna say partition 1. That's the one because there is no other partition on the disk here, okay? So I'm gonna hit enter, and it's gonna say here the first sector is how many sectors you want to use here. Okay, so we're gonna use it with 1024 and hit enter. All right, so let's see, primary partition.
So what do you mean by sector?
On the disk, on the disk, let's see here. So this is how the hard drive is. Inside that little hard drive, there are actually bunch of disks on top of each other, okay?
Okay.
And let's look at it here. So this, it says sector. Okay, this one is much better. So the sector is this size here. Each size,
Okay.
each block is a sector here. So the
Okay.
starting single block is 2048. Okay.
Is it in MB, sir?
No, this is 2048 bytes.
Bytes. Okay.
Okay. And now is asking what is the size you want to give. Okay, so what I'm gonna do is I'm gonna give the size. Let's see here. Uh, so I'm gonna give the size. What size should I give? Okay, I'm gonna give the size about 2 GB or 4 GB. Let's do 4 GB. Okay, so you have to type 4G. Okay, and hit enter. No, I'm sorry, you have to type a plus sign plus 4G, and it's an uppercase G. Okay, okay, so now we have completed at least minimum requirement to configure the disk. Okay, and then I'm gonna push M for menu, and then we're gonna push P for a print partition table here. So I'm gonna push P and hit enter. So this is the partition we just created. So this is the partition we created. So the starting block is sector is 2048, and this is the ending sector, and this is the size it occupied. Okay, and these are the blocks, and this is the ID for the system. What kind of system is going to use? It's going to use a Linux system here. Okay, so let me copy this. Okay, now to save the changes, you have to type write W and exit. So when you type W, it will write the disk. It will write it to the operating system here. So operating system will remember this. Okay, this is the disk that is just been created here. Okay, so how are you gonna do this? We're gonna type W and hit enter. Okay, so we are back here. The partition table is written here. So you have to type the, let's do lsblk first. Okay, so now what is it doing here is, you see SDB, and it's a hard drive, physical hard drive, and then in there SDB1, okay, and this is the partition drive. So there is also a command type part probe. Okay, remember we used mod probe. This is a part probe. What this will do is this will look for any drives, and if it does not show up in operating system, it will register an operating system here. It's already registered, so but it's a good idea to do this. lsblk. Okay, so let me copy this. Now you type lsblk. and this is the physical drive, and this is the partition on the drive. So now let's see here, this space okay, so the disk is this, we made the partition but it's not ready yet. So what I'm going to do is we have to make it a system disk here. So the command is mkfs make system dot ext4. Okay, I'll come to this. What is ext4? It's a file system. Okay, /dev/sdb1.
Sir, can you repeat again what we are doing with this MKFS extension 4?
Yeah, so what we did was we have the hard drive here, but its hard drive is not ready yet. So have you ever heard the term format the disk in Windows environment?
Yes, sir.
Okay, yeah. So what this is doing is this is making the disk ready here, but that's what it's in simple terms, but in complex terms, it is writing the file system here. So we'll go over how the file systems is and what are the advantages and disadvantages. So the file system, this disk we use is ext4 here. So we'll go over this in a little bit, okay? So now what happened here is when we ran the command, it went through a bunch of things here. So the important ones, let's take a look here. So we created this file system label, is not there yet. OS type is operating system. Block size. Okay, so these are the, okay, let me copy this. These are the important things, not all of them, but I'm going to discuss some of them here. Okay, so let's see here. So we have a block size here, 4096. Okay, and what else I'm gonna worry about is okay. Okay, so let me explain what block size is, okay? Block size. So the block size is the disk size, uh, disk space used by the file. Okay, so in this case we have a block size of 1046. So each block is 1046. I'm sorry, 4096. 4096 bytes. I don't want to go in there. So what we have here is, we have, remember each byte here, we went to 000 and we have like 1 2 3 4 5 6 7 8. Where is this coming from? This is coming from 2 to the power of 8. Okay, so when you do this here, each byte is one information here, 1 byte. So any byte it's taking here, it has 8 bits in it. Okay, so 1 byte, it got 8 bits in it, and 1 kilobyte it got like 1024 bytes here. So let's do 1024 times 4 is 4096. So 1024 is 1 kilobyte, and how much is 4096? How many kilobytes is this? 4 kilobytes. Okay, this is a good picture. Let me copy this. Okay, so okay, the disk space used by the file, block size is 4096. Okay, so how much is this? This is 4 kilobytes. So our basic bucket here is smallest bucket that holds the file information or the file data is 4 kilobytes here. Okay, so if we have, so this is 4 kilobytes. Okay, if the size of the file is 1 kilobyte, okay, if the size of the file is following, Okay, if the file is 1 kilobyte, so if the size of the file is 1 kilobyte, how much disk is being used anyway?
4 KB.
Yeah, very good. If the size is 1 kilobyte, the 4 KB is disk is used. 4 KB disk is 4 KB disk is being used. And if you have a new file, it's not gonna that 4 KB is used up. If you have like a new file, then it won't use that one. So out of 4 KB, 3 KB is getting wasted here, okay? And if it's 2 KB, 2 KB, still 4 KB is being used. Okay, and if it's 4 KB, then it's at maximum capacity. 4 KB is being used. Okay, now what about if the file size is 6 KB? How much is it going to use?
KB then?
How much?
8 KB.
How much you said?
8 KB.
Okay. Both of you are saying 8 KB, right? Yeah, very good. So 8 KB is disk is being used. Okay. So this is how it works. Here, so 2 KB is getting wasted here. And then if it's 9 KB, then 12 KB is being used. So it goes into the increment of 4 kilobytes here. Okay. So that is how it works here. And now file system. The one that we're gonna deal with is we used to deal with so if you do the math here, this is the minimum size here. So these are all the blocks in here. Maximum file system block is block size is this here. So you have is it multiplying this and with this? Give me 1 second here. So 4096 is the base here. So with all this calculation here. So I'm going to copy this and divide it by 4096. So you get this number here. 26214 are inodes, and so the block size is this much here. Inodes is the each file that gets its own number. We talked about inode number, right? We talked about inode number. Don't tell me we didn't. Is it in basic commands?
You might need the search feature.
Yeah, right here, inodes. Right? Yeah, right here. inode, it is a table on the so inode, it has all this information, is a table on the disk holding file information, owner, group, file permissions, and all this here. So in this chunk of hard disk, you could have 262,114 files here. So the maximum number of inodes it could have is that number. Why that number? Because the minimum size of the file is 4 KB, and that many, if you divide 4096 with the block size, this is the number you get, is inode. Okay, and this is a lot of information here, but it's for what we're doing, it's not, we don't need to worry about all this here. It used to matter a long time ago, but this size in these days is almost unlimited here. Nobody's worrying about this. And back in the day, we used to worry about if the disk has a single corrupt sector on the disk, that means it's going to get replaced here. Back in the day, disks were expensive, so you would just continue using it until the disk completely dies here. So don't worry about that too much. So what else I have here is block size, the disk size, block 0 stripe, inodes, and then this is the blocks. Okay, so how do we get those blocks? Here is 20 blocks, 5% reserved for super user, first data block 0. The group. Okay, yeah, you don't stress too much on it. So let's talk about the file system here. Okay, so now file system, one, two, three, four. Okay, and oops. Okay, so I'm going to type file system, and let's see here. You know what? Give me one moment here. I'm gonna put you on hold. I got a call here. Okay, I'll be back in 2 minutes.